When working with large numbers, such as the fraction 1248 over 1679, it can be difficult to tell if there is a number, in this case the greatest common factor, that both of the numbers can be divided evenly by, to reduce the fraction to its lowest terms. The rules for divisibility may be able to help. The rules for divisibility are a shortcut method to find out if a given number is divisible by another number without having a remainder. A number is divisible by 2 if the last digit is 0, 2, 4, 6, or 8, so if it's an even number. For instance, the number 1256. 6 is the last digit, so it is evenly divisible by 2, and you can see that here, as it has no remainder. The number 24,567 has 7 as the last digit, so it is not evenly divisible by 2. As you see, it has a remainder of 1. A number is divisible by 3 if the sum of all the digits is divisible by 3 without a remainder. For instance, the number 3,258. If we add up all of the digits, we get 18, which is evenly divisible by 3. No remainder. For the number 44,587, if we add up all the digits, we get 28, which is not evenly divisible by 3. So 44,587 is not evenly divisible by 3. As you see here, it has a remainder. A number is divisible by 4 if the last two digits is divisible by 4 without a remainder. For instance, the number 21,552. The last two digits is 52, which is evenly divisible by 4, no remainder. For the number 633, with 33 being the last two digits, it is not evenly divisible by 4, and you can see it has a remainder. A number is divisible by 5 if the last digit is 0 or 5. For instance, the number 104,495. 5 is the last number, so it is evenly divisible by 5. And you can see that here, as it has no remainder. The number 62,541 is not evenly divisible by 5 because the last number is 1. A number is divisible by 6 if the number is evenly divisible by 2 and 3. So looking at our chart, the number must be an even number. That is, the last digit must be 0, 2, 4, 6, or 8. And the sum of the digits must be divisible by 3 without a remainder. So the number 6,420 is evenly divisible by 6 because it is an even number. The last digit is 0, and if we add up all of the digits, we get 12, which is evenly divisible by 3, no remainder. And the number 8,420 is not evenly divisible by 6 because if we add up all the digits, we get 14, which is not evenly divisible by 3. As you see here, it has a remainder. A number is divisible by 7 if you cross off the last digit, double that digit, and subtract from the remaining number. And that number is divisible by 7 without a remainder. For instance, for the number 217, we would cross off the 7, then double the 7, which is 14, and subtract that from the remaining 21, which is 7, which is divisible by 7. So 217 is divisible by 7. And if we tried this process for the number 317, we would cross off the 7, then double the 7, which is 14, and subtract that from the remaining 31, which is 17, which is not divisible by 7. So 317 is not divisible by 7. A number is divisible by 8 if the last three digits is divisible by 8 without a remainder. For instance, the number 31,568. The last three digits is 568, so we divide 8 into that, and we see that there is no remainder. So 31,568 is evenly divisible by 8. And the number 1,549,748 has the number 748 as the last three digits. And this is not divisible by 8 as there is a remainder. So 1,549,748 is not divisible by 8. A number is divisible by 9 if the sum of the digits is divisible by 9 without a remainder. For instance, the number 3,267. If we add up all the digits, we get 18, which is evenly divisible by 9, no remainder. For the number 44,509, if we add up all the digits, we get 22, which is not evenly divisible by 9. So 44,509 is not evenly divisible by 9. As you see here, it has a remainder. A number is divisible by 10 if the last digit is 0. This one is pretty basic. The number 56,640 would be divisible by 10, and the number 3,155 would not be divisible by 10 based on its last digit being a 5. Alright my friends, hopefully you got something out of this video. I do have more videos right there for you. Till next time, I am out of here.